All right, everyone get ready, because today we are going deep on a topic that everyone's talking about.
Yeah.
Nvidia's Nano Supercomputer.
It's really interesting.
And this isn't just like some new gadget or something.
That's right.
This little device, it's got enough power to maybe even change like who gets to innovate, you know?
It really could.
And how. So imagine like groundbreaking research or, you know, really cool AI and all that happening outside those giant, you know, expensive labs that you usually think of for that kind of stuff. And the crazy thing is, this supercomputer power is less than like your average fancy phone.
Less than a high-end phone, for sure.
It's crazy.
Yeah. For a long time, you know, if you wanted to do anything serious with computing power, you'd be stuck with these like these big server farms. Only people with tons of money.
Yeah.
And resources could get in there.
Exactly. Yeah.
But the nanos, it's like changing everything, changing the whole game.
It's like Nvidia's like giving out like VIP passes to this like supercomputing world, you know.
Totally.
But before we even get into like the Nano itself, I'm curious how Nvidia, a company everyone thinks of for like gaming graphics, even got into like
how did they
the supercomputer world?
Well, it's really interesting.
Yeah.
They started back in the 90s focusing on these things called GPUs, graphics processing units. And at first it was just for gaming mostly. But over time they realized, hold on. These chips, they're incredible at like handling really complex calculations, the kind of calculations you need for AI and data science, all this stuff. And it's like they discovered this gold mine of computing power that could do way more than just make games look pretty.
Wow, so they went from like powering like virtual world to powering like breakthroughs in the real world.
And their expertise in GPUs. I mean, that laid the foundation for the Nano. But the real turning point, I think, was back in 2006 when they introduced CUDA.
CDA. Now, fill me in. What is that exactly?
So CDA is a parallel computing platform and programming model. Imagine like you're trying to solve a really complex puzzle, right? You could do it by yourself, or you could have a whole team working on it at the same time. So CDA is like having that team.
It lets developers use the power of like multiple GPU cores all at the same time to tackle these problems in parallel. So things get done way faster.
So that's how they unlock the full potential of those GPUs.
Exactly.
That's how they do it.
It's making sense now. Why Nvidia is like leading the way in high performance computing.
CUBA opened up a whole new world of possibilities. And it's a core part of what makes the Nano so powerful.
Okay, I'm officially intrigued. So let's get into the Nano Supercomputer itself.
Let's talk about it.
I'm still wrapping my head around the fact that something so small can even come close to these like massive server farms. What kind of power are we talking here?
So think about the kind of power you'd need to analyze enormous data sets, like to train AI models that can like diagnose diseases or predict climate patterns. I mean, traditionally that took huge systems, expensive systems. The Nano puts all that within reach. For a fraction of the cost.
Like $249.
It's $249.
That's less than I spent on my last weekend trip, and we're talking about a supercomputer.
It's
wild.
It's a game changer. It's a game changer. The Nano, it packs, you know, enough punch to handle, you know, really complex calculations, run like intricate simulations, process massive amounts of data, all this stuff that used to be totally out of reach for most individuals and small organizations.
I bet people listening are like already thinking about how how they could use this, you know? Like no more needing $1 million lab to do this cutting edge kind of work.
Exactly.
But what does this actually look like in practice? Like give me a real world example.
Okay, let's say you're a researcher studying like the effects of climate change.
Great.
With the Nano, you could run these complex climate models right on your desktop.
Wow.
You know, you could analyze data and contribute to like really important research without needing access to this massive supercomputing facility.
Wow. So you could potentially have like scientists all over the world from small universities to independent labs all making these groundbreaking discoveries, all thanks to this little device.
It's amazing. And it's not just limited to research either. Like think about AI development. You know, startups or individual developers could build the next generation of AI-powered tools and applications all from their home offices.
So it's not just like about accessibility. It's about like unlocking.
It's unlocking potential that wouldn't have been possible before.
Yeah, like this whole wave of innovation.
Exactly.
That's pretty amazing.
Yeah.
This Nano's starting to sound like
that's pretty cool.
Like a key to the future, you know.
Yeah.
But before we get like too carried away with all the possibilities, let's take a step back and compare the Nano to those traditional supercomputing systems.
Yeah.
Paint a picture for me.
Okay.
What's the difference?
Okay, so picture this.
Yeah.
You've got this vast server farm.
Okay.
Right? Humming.
Yeah.
With thousands of processors consuming tons of energy, needing constant maintenance.
Yeah.
That's your traditional supercomputer setup.
Yeah.
Now imagine shrinking all that power down to a device that fits on your desk.
Right.
That's the Nano.
Wow.
It's incredible.
It's almost like David versus Goliath.
Oh, totally.
In the world of supercomputing.
That's a great way to put it. And it's not just about size and cost.
Right.
The Nano also uses way less energy than those giant server farms, which is huge for like sustainability and environmental impact.
Okay, hold on. My mind is officially blown.
It's a lot.
This tiny device is not only powerful, but it's energy efficient too.
Yeah, and it's like they're rewriting the rules of what's possible in computing.
Totally. Yeah. All right, deep breath.
Okay.
I'm ready to go even deeper.
All right.
So far we've talked about like the Nano's potential impact on research and development.
Okay.
But what about its like real world applications?
Oh yeah.
Like what are some like tangible ways it's already being used?
Yeah, like how is it actually being used?
Yeah, like out in the wild.
That's a great question, and that's where things get really, really interesting.
Yeah.
But you know what? Let's take a quick pause for now, and we'll pick up right where we left off in part 2
of our deep dive.
Okay. Welcome back. Before the break, we were talking about how the Nano is really, changing the game in terms of access to serious computing power.
Right.
So now I think let's actually zoom in on some
let's see it in action.
Yeah, some real world examples of how this little device is making a big impact.
Yeah, give me the specifics. Like what's out there that's using the Nano to do cool stuff.
So one of the most like exciting areas is AI development.
Oh, okay.
Remember we were talking about CDA and parallel processing?
Right.
That's key to the Nano's ability to like train and deploy these really complex AI models.
So I'm picturing like doctors using AI to analyze like medical scans and things. Yeah. Is that the kind of thing?
Like think about the potential to detect diseases like cancer earlier with greater accuracy.
Wow.
Researchers are using the Nano to develop like AI algorithms that can go through huge amounts of data and spot subtle patterns that might be missed by the human eye.
So the Nano's not just like helping doctors.
Right.
it's potentially saving lives.
Yeah. It's powerful stuff.
Pretty powerful stuff.
It is. And it's not just limited to medical imaging either.
Okay, what else?
We're seeing the nano being used to develop AI-powered tools for drug discovery, personalized medicine, even robotic surgery.
This is starting to feel like we're like
it's pretty wild.
Living in a sci-fi movie, you know. Like what other applications are out there?
Let's talk about education. For a long time, like the cost of equipment has been a huge barrier for students who want to learn about fields like AI and robotics.
Okay.
The nano changes that.
Okay.
Like imagine a classroom where every student can design their own robot or train their own AI model.
It's like giving every student a chance to be like a hands-on innovator. You know?
Yeah.
That's a far cry from just, you know,
it's a whole different
reading about AI in a textbook.
It really is. With the nano learning becomes experiential.
Yeah.
Students can experiment, test their ideas.
Yeah.
See their creations actually come to life.
I'm seeing a pattern here. Like the nano seems to be all about taking things that were previously out of reach and making them accessible.
Totally.
Almost like it's leveling the playing field.
Yeah.
You know?
That's a great observation.
Yeah.
And it goes beyond just, you know, research and education.
Yeah.
It extends to creative fields as well.
Okay.
Like think about independent filmmakers, animators, game developers.
Okay.
A lot of times they don't have access to those high-end workstations that the big studios use, but with the nano, they can produce professional quality content without breaking the bank.
So we could see like an explosion of creativity from people who might not have had like the resources before.
Totally.
It reminds me of when like personal computers first became popular. Like suddenly everyone can make music, write stories, create art. It was like a whole new world of.
It was a whole new world of possibility.
That's a great analogy.
Yeah.
It's why the nano is so fascinating.
Yeah.
It's not just a powerful tool. It's a catalyst for change.
You know, we've been focusing on like the positive aspects of the nano,
of course,
which are clearly huge. But I'm also wondering about the bigger picture. You know, like what are the potential societal impacts of having this kind of computing power so readily available? Are there any concerns?
We should be thinking about.
Yeah, it's important to consider you know both sides of the coin here. While the potential benefits are enormous, there are definitely challenges that come with this level of technological advancement. For example, as AI becomes more and more sophisticated, we need to be mindful of its ethical implications. You know, how do we ensure fairness and avoid bias in AI algorithms? These are questions.
It sounds like we need to have some serious conversations about how to harness the power of the nano responsibly.
Absolutely. Yeah. It's not just about you know, technological innovation. It's about shaping the future in a way that benefits all of humanity. And that requires, you know, thoughtful dialogue, careful planning, a willingness to consider the potential consequences of our actions.
This is getting pretty deep.
It is.
But I appreciate you bringing up those points.
Of course.
It's a good reminder that even the most exciting, you know, advancements come with responsibilities.
They do.
So where do we go?
Okay,
from here, what are like the next big things to watch for in the world of the Nano Supercomputer?
One thing to keep an eye on is the development of new applications. As more people get their hands on the nano, we're bound to see a surge of creativity and innovation. People people will find new ways to use this technology that we haven't even imagined yet.
That's what's so cool about technology.
It is.
Like it's constantly evolving.
Yeah, evolving.
Yeah, what about the Nano itself?
Yeah.
Will it continue to...
Oh, absolutely. Nvidia they're constantly pushing the boundaries.
Okay.
We might see even more powerful versions, more specialized versions that are tailored to specific industries. Who knows?
Right.
The possibilities are...
It feels like how much endless.
The possibilities are endless.
Yeah.
All right, I'm officially back on the excitement train.
It's exciting stuff.
This Nano really does feel like it's opening up a whole new
era of innovation.
Yeah, it really is.
Before we get too carried away, let's take another quick pause. We'll wrap things up and leave you with a final thought to ponder in part 3 of our deep dive.
Yeah.
Welcome back to the final part of our deep dive into NVIDIA's Nano Supercomputer.
Yeah, we've
covered
a lot.
A lot of ground from its origins in gaming graphics.
Yeah, gaming graphics
to its potential to
pretty crazy.
Revolutionize whole industries.
It's pretty wild, yeah.
It's pretty wild.
Yeah.
But before we sign off, I want to revisit something we've talked about a few times, this idea of democratizing computing power.
That's really at the heart of what makes the Nano so significant.
Yeah.
You know, we're talking about giving individuals and small organizations access to this computing power.
Yeah.
That was once only avaavailable to massive corporations.
Yeah, or research institutions.
Research institutions. It's it's leveling the playing field for innovation.
It's about putting everyone on a more equal footing.
Yeah, and that raises a really interesting question. What happens?
What happens
when this kind of power becomes widespread, available?
Yeah, what are the ripple?
What are the ripple effects on society?
Yeah, what are some?
One possibility is an explosion of innovation in fields like AI, biotechnology, material science.
Right.
We could see a surge of new startups and independent researchers just pushing the boundaries.
It's almost like the early days of personal computing, you know?
Right.
When people suddenly had the power to create
and innovate in ways they never could.
In ways they never could before. Totally.
That's a great parallel.
Yeah.
We could see a similar wave of creativity and entrepreneurship just fueled by the accessibility.
Yeah, fueled by the accessibility.
With the Nano.
Yeah.
Yeah.
That's an exciting prospect.
It is exciting.
But we also talk about some potential downsides earlier.
Yes, we did talk about some of the
what are some of the
challenges.
What are some of the we need to be
the challenges that come with this,
prepared for,
as with any powerful technology.
Right.
There's always the risk of misuse.
Right.
We need to be really, really vigilant about the ethical implications.
Ethical implications of AI.
It's AI, making sure it's developed and used responsibly.
Yeah, responsibly.
We also need to, think about, address concerns about potential job displacement as automation becomes more
sophisticated. So it's not just about embracing the possibilities.
Right.
It's also about
it's also
navigating the complexities
that
come with this kind of technology.
Yeah. This has been an incredibly a really interesting
conversation.
I've gone from knowing very little about the Nano to being completely amazed by its potential.
It really is a remarkable testament to human ingenuity.
Totally.
And it's just exciting to think about what the future holds.
Yeah, before we wrap things up, I want to leave our listeners with one final question to ponder.
Okay.
If computing power becomes as cheap and accessible as it is with the Nano, which becomes
what becomes the new bottleneck?
A new bottleneck. Is it our imagination, our ability to ask the right questions, or maybe our capacity to collaborate effectively across disciplines?
That's something to think about.
Yeah, that's something to consider as you kind of continue exploring the world of technology and its impact on our lives.
Thank you for joining us on this.
Yeah, it's been incredible
journey into the world of Nvidia's Nano Supercomputer.
Yeah, thanks for having me.
We hope you've enjoyed the deep dive.
Yeah.
And we'll see you next time.
Yeah, see you next time.
For another fascinating exploration.